So I wanted to talk a little bit about this opportunity for harnessing AI in the world. And I wanted to point out, just in a few panel comments here, that my experience has been that it takes quite a bit of effort to engage with domain experts. AI experts have to engage deeply and almost become experts. And often success takes collaboration with government, industry, academia, and civil society. And if I can have the next slide, just want to make the comment that there are different models of engagement. I've experienced quite a few over the years, and I have trouble generalizing. There's been quite a bit of custom tailoring that goes on with any application. Next slide. So I wanted to point out that for success, looking at the program today, and I wish I could have been with everybody this week, but I had to be here in the U.S. I find that we need to have coalitions around expertise, infrastructure, and data. And expertise is very important for even selecting the problems, identifying pain points, understanding possibilities in the open world outside the computer science laboratory. We often find there's quite a bit of infrastructure we can harness, human resources, if we engage deeply with domains, the actual specific areas like healthcare, for example. And there we find access to data streams and data sets often hidden and often part of the dark matter of a domain. So if you want to go to the next slide, I want to give a couple of directions. One comment is that I see the word AI used a lot on the program. Regulation of AI, AI safety, but AI is really, it's not one thing. It's not one blue-green gas. It's a set of rich subdisciplines and methods: vision, perception, speech and dialogue, decisions and planning, robotics, and so on. And we have to consider all these different disciplines and methods in thinking through solutions and delivering value to human beings and to organizations. Next slide. And one way I like to think about a really beautiful way to perspective on developing applications is the pipeline of going from sense data to probability distributions to actions, data to predictions to decisions, and then back up again. Once you set up a pipeline in a domain, to think about how much data is worth, how much more data would be worth, how much better could we do with more information. Next slide. Next slide. And it's often not about automation, but about use cases where you have decision support. It's not about autonomy necessarily. There's a human-computer richness and collaboration. Next slide. So let me just take a quick example here of some high payoff areas, just as examples we've been involved with over the years. So let's take cholera, which is a big challenge with about 100,000 people estimated dying per year of cholera. And I want to sort of point out this model of domain knowledge, expertise, and models of engagement. Next slide. So it turns out that with getting appropriate hydration therapy to people in epidemic areas of cholera, you can go from a 50% mortality rate to a 1% mortality rate. The idea of getting fresh water distributed on time and in the right place at the right time is critical. Another interesting decision problem is there are short-acting vaccines for cholera that don't last very long. If you had predictions about where cholera might be occurring on the horizon, you could actually direct in an efficacious way where a vaccine program should happen every couple of years, for example. Now, 5 years ago, I worked with Kira Rudinsky, and we developed models to predict where cholera would come months in advance, weeks in advance, and days in advance, basically power up planning algorithms that could be used to distribute fresh water and to actually just as part of design programs for figuring out where to apply vaccines over time. Without that kind of predictive modeling, which came from multiple heterogeneous data sources, large-scale data sources, we would be in the dark. We act in real time to an epidemic. We don't understand how to optimally set up the plumbing and infrastructure to get fresh water to the right place. Next slide. So as an example, in reaction to an epidemic in Haiti, the World Health Organization quickly sent, 1 million doses quickly in response. But these things it's too late and it's too expensive to do without rich predictive modeling. This kind of example of an application area, understanding its value, understanding where methods available today could be applied, comes from this deep engagement of domain experts and AI researchers. Next slide. Often it turns out that we have incredible assets if we just look for them. So as an example, this gives you a snapshot of what Western Europe, in this case North America, but they're all very similar these days, looks like in terms of the number of planes flying over the continent right now. Ashish Kapoor and I worked several years ago to work, and we engaged the FAA, the U.S. government regulatory agency for flight, to gain access to ground radar tracks of airplanes. And we showed how, with a rich machine learning model, we could take all these airplanes as sensors and build rich weather maps for the country. And we're now showing how this applies to Western Europe and Asia. Next slide. So you can build a live service. In this case, we call this Windflow. It's a live cloud service, we joke, that's dynamically updating winds much more precisely than the agencies that currently exist based on balloons, all by leveraging existing infrastructure and asking the FAA for the data that should be available for human welfare. Next slide. Here's another example of several years ago. We looked at some earthquake data and models for how we might help people deal with disruptions and understand disruptions and need for surveillance, looking at this Lac Kivu earthquake that hit Rwanda in 2008. Next slide. It turns out that there's a cell tower system in Rwanda that could be used as a sensor network. We work with the Rwandan government, which provided anonymized cell tower data of 3 years of cell tower calls. That's 140 cell towers, but about 10.5 million calls over 6 days. Next slide. And we could show with AI-related technologies, planning, decision-making, machine learning, how we can actually use the cell towers, look at the bump of the calls that come in around an earthquake to actually predict the epicenter of the earthquake. Next slide. Within about 17 kilometers outside the country in the Republic of Congo, from just the cell tower calls, human call levels changing over a region of 140 cell towers. Next slide. We then showed how you can actually look at disruptions over time in call densities to compute opportunities for assistance based on persistent disruptions. Next slide. And then showed with the Decision-Theoretic planning model how, given the uncertainty in our inferences about where we could most assist, provide help to people potentially in need after a disruptive phenomenon like an earthquake, where to look, how to triage, where to send surveillance resources, understand more, to ideally collapse the uncertainty. Next slide. So I think we need to start looking at the community, using together coalitions of governments, private sector, civil society, to build resources like the AI for Development resource of sets of data for use in leveraging for AI for social good. Next slide. Get a sense for the kinds of data that are available right now. These databases can be built and shared widely, and experiences with infrastructure can be shared widely as well. Next slide. Next slide. So I want to just end by saying these panel comments, there is so much to do, most of it can be done, or quite a bit of it, with AI methods available today. The constellation of AI methods, which is a rich fabric of methodologies, requires us, in leveraging opportunities, to work deeply with experts to understand where the pain points are and where we can get maximal benefit for people. And I'll stop the comments there.
Thanks, Eric. Thank you very much. I have a couple questions for you. And also after that, can you stay for a little while? We'll have the session of questions after Neil speaks, and then we can take the question from audience as well. My first question is, where are you and what time is it there?
I just arrived from Washington, D.C. to return to Seattle, and it is 4:55 here.
We should give him a hand.
In the morning.
4 o'clock in the morning.
Well, I have it easy. You guys traveled out all the way out from different countries, so you had it be easier than me.
You're quite a trooper there, Eric. Quite a trooper. We really appreciate that. The second question for you is, this is fascinating examples that you give us. So what kind of challenges that you face when you're trying to predicting the weather or predicting the earthquake? Could you give us an idea about what kind of grand challenges that you face when you do those kind of projects?
Well, I think Peter Lee used the term artisanal AI. I think it really turns out that there is no cookie cutter approach to these technologies and ideas. We learn so much in every domain, and the models have to be iterated. We also start with intuitions and don't really know if we'll be successful or not. So, and then it turns out that when you try to push things hard into a service, even when you build, let's say, Windflow, which is an existing service with an API that can be called, convincing airline companies and weather reporting agencies that this is more accurate by far than the status quo is difficult. So there's a long process, a long curation process of working with multiple stakeholders, understanding how data is used, how inferences might be consumed. Think about healthcare, just to jump to a topic here. I'm just absolutely shocked. If you told me when I was in grad school studying AI and medicine in the late 80s that here we are in 2017, and here is today how AI is being used in medicine, I would be absolutely shocked with how little progress has been made outside the laboratory. So there's all this real-world impediment. It has to do with human beings, with the realities of ergonomics, of the flow of life and the flow of activities that often have to be encountered and really dealt with deeply and worked out to understand why we don't make better progress with taking ideas that are mature in the laboratory but somehow seem premature or immature for the real world.
Actually, what you said really is resonance with this session here. What we talked about trying to convince government, convince the industries to be able to adopt some of the technologies that you talked about. That is going to be a big challenges for any of the researchers or any advanced technologies. So thank you very much.